All right, so here we are checking out learning target 8, looking specifically at convection currents underneath the crust and focusing on how these ridge push slab pull interactions move the surface layer. So we've got two parts to our learning target. We've got the diagram with a few things to include and label, and then we have our descriptions. Okay, remember when you're thinking about these things, we always want to be looking at our classroom stuff, right? This is not supposed to be just a guess. We want to grab what we practiced with and apply it here. So this assignment, tectonic forces, is where we want to be. We have this beautiful notes diagram, all these practice drawings. This is a super awesome resource. So when you're working this learning target, this should be up just like mine. So let's start here. We're making this diagram. We've got two arrows that we want to include on our picture. We've got red arrows, of course, for the warm, and we've got cool arrows to represent blue. We want to include those in our lower layer, or the asthenosphere. That's this.
Fish for lunch today, huh?
And we want to show how the movement here makes our lithosphere move.
The more tartar sauce you have, the better.
So when we're thinking about how the interior moves, it should match how the exterior moves. So I already see these arrows moving down this layer. So I know the underneath has to parallel that. So I'm looking at drawing in my arrow to show that movement, and I want to carry it as long as I can along the crust. Okay, when I see these drawings, guys, what we have here is a big dead air space or dead zone, right? There's nothing happening here to move this piece of crust. So I want to have that interior movement parallel that lithosphere for as long as I can. And then we know this should just be a great big circle, right? So I've got the sinking arrows down. I know it's getting reheated by the mantle, and it's going to work its way back up to finish this full cycle. So there's one convection current. I should also be able to draw part of one over here. And remember, they're symmetrical, same on both sides. So whatever happens here, warm rising, I should see the same here, allowing that material to rise up, causing the crust to separate. And so I should be able to then label this as the right type of plate boundary for the separation. And I'm seeing a similar thing right here. This side, again, I have the sinking. This is the second boundary. Looking at the arrows, we should be able to label what it is. And then, of course, you should be color coding with red or blue, depending on the motion of the arrow and the temperature of the stuff. The other thing we're thinking about underneath is, well, what force do we have, ridge push or slab pull? So again, looking at our notes, we've got details about that convection movement. So we should be able to circle up on here which is which. And then this bottom section is simply a describe of that. So talking through what the convection is for ridge push and the boundary that it makes. So when we talk through the convection, we want to make sure that we're including temperature, density, so either more dense or less dense. We want to include the motion and where it's happening and how it allows that upper layer to move. And then, of course, the boundary that it connects to. So again, using your notes, we're just plugging in a summary here, and you should be looking back at those sentence starters and hints, seeing, okay, ridge push is created by material in the asthenosphere moving this way. It's moving this way, creating because of this temperature and this density. Here's the boundary it makes. Slab pull. Moving this way because of this temperature and this density. Here's the boundary it makes. So we're giving those details here. As always, reach out with questions you have.